Hello, I'm Mrs. Stevenson. Gas laws. A 20-liter sample of argon gas at 273 Kelvin is at atmospheric pressure, 101.3 kilopascals. The temperature is lowered to 120 Kelvin, and the pressure is increased to 145 kilopascals. A. What is the new volume of the argon sample? B. Find the number of moles of argon atoms in the argon sample. And C. Find the mass of the argon sample. The molar mass M of argon is 39.9 grams per mole. The picture shows a visual representation of the volume of the gas changing when the temperature and the pressure are changed. Some of the knowns are written out on the screen for you. We do have some other knowns in the problem. We know that our temperature is 273 Kelvin. We know our pressure in the initial sample is 101.3 kilopascals. Our volume in the initial sample was 20.0 liters. We know our temperature in the second was 120 Kelvin. Our pressure in the second was 145 kilopascals. But we also know there is a constant called Boltzmann's constant, which is 8.31 Pascal meter cubed per mole Kelvin. And we are also given the molar mass of argon, which they called capital M of argon, as 39.9 grams per mole. So these are all of our knowns. Our unknowns the question is first asking us for the new volume of our sample, so we do not know the volume of the second container. It's asking us for the moles of argon and the mass of the argon sample. Remember, AR is the symbol for argon. In order to solve for the first portion of this question, we need to use the combined gas laws. The combined gas law is that the pressure in the first container times the volume of the first container divided by the temperature of the first container is equal to the pressure of the second container times the volume of the second container over the temperature of the second container. Because we want to know the volume of the second container, we need to rearrange this expression in order to solve just for V2. So the first, we're going to multiply by the temperature of the second container to get that out from the bottom of a fraction. So when we multiply, those cancel. So we now have pressure of the first container times the volume of the first container times the temperature of the second container divided by the temperature of the first container is equal to the pressure of the second container times the volume of the second container. Now to get the V by itself, we need to divide both sides by the pressure of the second container. This cancels. So we are left with the expression for the volume of our second container as the pressure in the first times the volume of the first times the temperature of the second divided by the pressure of the second times the temperature of the first. All of these values were given to us in the problem as knowns, so we can go ahead and plug those in. Oops. Our pressure in the first container was 101.3 kilopascals. Our volume of the first container was 20.0 liters. Our temperature in the second container was 120 Kelvin. This is all divided by the pressure of the second container, which was 145 kilopascals, times the temperature of the first container, which was 273 Kelvin. Before we even multiply and divide all of our numbers, we can cancel out some units. We have a kilopascal on the top and a kilopascal on the bottom, so those cancel. We have a Kelvin on the bottom and a Kelvin on the top, so those cancel. So we're left with liters, which is a unit for volume, so we know we're on the right track. When you multiply your top three numbers and then you divide by your bottom two numbers, you end up with a final volume of 6.1 liters. Now for the rest of the problem, we are asked to calculate the moles of the argon sample and the mass of the argon sample. In order to solve for the moles of the argon sample, we need to use the expression P, which stands for pressure, times V, which stands for volume, is equal to N, which represents our moles, times R, which represents Boltzmann's constant, times T, which represents temperature. Because we are calculating for moles in this problem, we want to rearrange this expression to get N by itself on one side of the equation. In order to do that, we need to divide both sides of our expression by the constant R and T, which stands for temperature. Do it on both sides of our equal sign. And then it cancels on the right side so that our new expression that is rearranged states that N, or moles, is equal to P, which is pressure, V, volume, all divided by the constant R times temperature. Because the constant R uses the unit pascals instead of kilopascals, we need to convert our pressure from kilopascals to pascals. Our converted pressure is 101.3 times 10 to the third pascals. We need to multiply this by our volume, and because the constant R uses the unit meters cubed for volume, we need to convert our volume into meters cubed, and our converted volume is 0.0200 meters cubed. This is all divided by our constant, which is 8.31 pascals meters cubed divided by moles K, and the K stands for Kelvin, which is the unit for the temperature, times our temperature, which is 273 K, or Kelvin. And last but not least, we are going to calculate the mass of our argon sample. And the expression we will use for that is M is equal to capital M times N. The lowercase m stands for the mass, the capital M represents the molar mass, and the N is the number of moles. To calculate this mass, we are going to plug in some known values. We were given the molar mass at the beginning of the problem, and that is 39.9 grams per mole. And this is times the number of moles we just calculated, which is 0.893 moles. We've got a mole on the bottom and a mole on the top, so those cancel. And our final answer of the mass of our argon sample is 35.6 grams of argon.